Thank you for joining us today. Today we've got Simon Pink. Simon is one of the Harrington Starr technology consultants. Simon's on a trailblazing project at one of our key asset managers here in London, and he's going to be talking to us today about APIs, API gateways, and later microservices. In the question time, we'll be able to deal directly with key issues that a lot of us are having with our finance implementations. Over to you, Simon.
Okay, welcome everybody. My name's Simon Pink. I'm a software developer. I currently work for an asset management firm, but I've been lucky enough to work with quite a few different companies and agencies over the years. One thing that I've really noticed is people really want to join the digital revolution or engage with cloud services, but don't really know where to get started. So to me, a lot of people have very similar problems and concerns, and a lot of those concerns to me revolve around APIs and the usage of APIs. So that's really what I want to focus on today. So I'll go through APIs in the digital revolution, talk about how they relate to gateways, how microservices relate to APIs, and any common problems that people face. And we'll have questions afterwards. So the world is running on APIs. Banks aren't being disrupted by fintech technology. They are being disrupted by customer expectations. That's quite an apt quote for today, really. Basically, everyone expects data to be available at their fingertips. So if I put a Facebook post on, I don't expect to wait for 24 hours for that post to come to arrive. And same thing for a tweet or a status update, etc. But we seem to accept that in financial services or in lots of industries that we can wait for the overnight batch to run or what have you, and I don't think we need to do that anymore. So in order to stay competitive, really what we're saying is that data needs to be available to people that need it. So why isn't that data available? Well, to me, one big reason is data is in silos. So what I mean by that is data is sort of trapped in these monolithic, slow-moving back-end systems, or the data is simply in systems that aren't capable of being of sharing data. So Excel spreadsheets, for example. So how do we get around that? Well, that really is where APIs come into play. So if you think about the world today, a lot of sort of websites, apps, corporate systems, the Internet of Things, everything really is driven by APIs. So if we move on to what an API actually is. Definition, application programming interface, it's sort of an old, dated sort of definition, but it's sort of been reappropriated for today to really mean a web service that provides an interface over your data and systems. So REST is a set of architectural principles that was laid out by Roy Fielding. Roy Fielding is one of the principal architects of the HTTP specification. Really, the driver behind REST was interoperability, performance, and scalability. One of the key features there is interoperability. Most or pretty much all systems these days can sort of read and process RESTful services much easier than you can process traditional sort of remote procedure calls, etc. So this is an example of what a REST payload looks like. So in this particular case, we've got a very simple get command, which returns some specific fund information. So we have a get fund 1234, 1234 being the identifier of the resource, and we have some basic sort of fund information and share class information. So you can see there it's over HTTP, which is what most REST it's the protocol that most REST APIs use, and it should look very familiar because it's just like you type into your web browser. So this is what the large majority of people do for REST. It's not sort of the endpoint that Roy sort of had in mind. He was thinking more of a semantic web. So what do I mean by that? Well, semantic web, he coined the term HATIOS, hypertext as the application hypertext as the engine of application state. So that's quite a mouthful, but the idea is actually quite straightforward. So this is probably the world's quickest overview of what HATIOS is, but just to emphasize really what he was getting at. So you can see here we've got the same payload, and the first thing that you notice is it's a lot more verbose, but what's it actually showing you? So within here we've got the same data, you've got but you have links to other related information that you might be interested in. So if you think of a website, the website by itself is probably a bit useless unless you've got links to related pages that you're interested in. The BBC homepage wouldn't just have information without links to its articles, and that's kind of what it's driving at. So the good thing with that is the state is purely controlled by the resource that you return. So this particular example is actually using HAL, which is an implementation of HATIOS, hypertext application language, which seems to be sort of the de facto standard in this space. So that said, again, unfortunately a lot of people don't do this because the client support isn't 100% there yet, but it's definitely something to keep in mind, and it's a way you can do versioning for your URIs, etc. as well. So that said, that's what REST is, but how can we use it? Really the idea is to expose your data, not your systems. So by that I mean you may have very old legacy monolithic systems. In this particular case I've actually got an Excel workbook, which is what a lot of companies sort of rely on these days, unfortunately still. But it could be a very slow moving legacy system as well. Then you've got people and systems that rely on that data. So really you want some separation there, because if I want to improve the source of this information from an Excel workbook to a real source, you have to let, in this particular case, 4 different systems know about it. And the 4 different systems would need to change their processing, their logic, how they connect to the back-end systems, etc. So what we really want to do is put in a facade layer in place. So in this case, we've got one dependent service that only needs the performance data. We've got 2 that require pricing information, and 1 that we haven't migrated yet. So it's important to note you don't need to migrate everything in one big bang sort of approach. But now what we've done is we've added a bit of separation of concerns here. So the users are unaware that they're talking to an Excel workbook or a legacy system, etc. So that gives us the ability to now improve the source system. So now we have performance coming from a more reliable source. The user is none the wiser. They're still connecting via REST. They don't need to know how we connect to, in this case, Morningstar. They don't need to know about any sort of RPC logic, SOAP logic, binary logic. They're just communicating over a known protocol over REST. And it gives us the ability to then just replace one of the sort of components of the legacy system, but we don't need to replace it all at once. So the next step, you might want to replace the source for pricing information. Right, so this all helps enable bimodal IT as well. So what is bimodal IT? So Gartner describes bimodal IT as the practice of managing 2 separate but coherent styles of work. One focused on predictability, the other on exploration. So in a nutshell, you've got very stable back-end monolithic systems that are very difficult to change. So if I want to run a new campaign or create a new mobile application, the time to market is quite large. So really you should have a system on top of that which adapts to change more aptly. So you can still have your monolithic systems, but it needs to be layering on top of that. So this is what this is really showing here. So we have system APIs. So basically, sorry, if we go back a step, gateway providers, so in this particular case, Apogee or MuleSoft, they actually both suggest 3 layers of sort of systems or what have you on top of your underlying monolithic systems. So the very first layer is your system API. So it literally sits on top of your monolithic systems. So the advantage of that is it hides the complexity of any connections, etc., to your data. So it exposes your back-end systems. So that's sort of your mode 1, or your slow-moving sort of system component. And then you have your process APIs stacked on top of that. Now what they do is they mash up data from sort of different system APIs. So again, this is sort of getting closer to quicker deliveries, etc. And the process APIs are more focused around your business processes and domains. So on top of that, again, you may or may not have experience APIs. So experience APIs are very highly targeted. So this is maybe creating very particular mobile app or web page or what have you. So they're probably very focused and sort of less reusable components, but they're very highly targeted for a particular use case. So with these three layers, now you can sort of leverage your data. Different teams can mash up the data for whatever purpose that they have in mind, and you should be able to get things quicker to market. This is what it looks like in practice. So we have our system APIs. In this particular case, we've got 3 different sources for share classes, and we've got 2 different sources for performance information. Our users really don't want to know or care about that. They just really want all of the share class information mashed up into one place where they can get all the share class information. Same for performance. So that's where the process APIs come in. They've sort of combined that information to a nice API. And on top of that, you might have very specific performance web page, which you'd have an experience API, which might connect share class and performance information. Another use case for experience APIs is if you want to, if a particular client has a different protocol they want to use as well. So client may need access to your APIs via SOAP or some legacy system, which is not easy to change. So that's basically how the layering works. So with all of that, you're going to end up with a lot of APIs. So how do you manage that? So I suggest heavily you should use an API gateway. So an API gateway, there's various different providers, and it's a quite up-and-coming space. But they all tend to offer the same kind of solutions. So, the same kind of features. So they typically offer sort of access control and security. So if you want, so I don't know, say I've got 60 different APIs, I don't want 60 different ways to authenticate. So it's a common way to authenticate. You might say, well, they all will communicate and sort of authenticate via OAuth. It's an API directory, so people within your company might want to see what API is available, or even external to your company. So you might have clients that want to see what APIs you've got available. So if you think in terms of public companies, Facebook, etc., they want to be able to publish what APIs people can use and can leverage and build their own products from. You've also got quota control, which is quite an interesting one. It's a way you can monetize your APIs. So you might have cases where your APIs are free, but a user can only call your API once an hour. Or you might have a gold package where a user might be able to call your APIs, 100 times a minute or what have you. That's a way to monetize your APIs. And then you've got a standard place through your performance monitoring, statistics, any logging. It's also a great place to do caching as well. Again, protocol translation and any payload manipulation. So if your target server requires slightly different headers which aren't sort of normal, you might want to do sort of a little bit of translation or payload manipulation on the way into your sort of underlying target server. And API proxying. So this is really where they come in. So you might have existing APIs. So the gateway will sit over top of those and simply proxy while offering all the other advantages. So that's what API gateways kind of are all about. So microservices. So what is a microservice? Well, in a way, we've already been talking about them because a lot of microservices are implemented via REST anyway. But really, it's almost a way of thinking. So microservices encapsulate business domains and business concerns. So really, they're built to be replaceable, stateless, basically completely standalone systems. The advantage of this, if I suddenly think, well, actually, I don't really like the technology this is written in, or what have you, it should be quite easy to sort of drop in and replace just one sort of component while still having the same sort of maybe RESTful interface, so it should be kind of invisible. So as an example, this is a sort of a legacy system or an application sort of system that's running today. So you can see we've got one application server or one server that's got 3 different applications running on it. So they're all talking to one database, and actually we've got a legacy system there which is connecting directly to the database, bypassing the application layer altogether. So that's what a lot of systems are built like today. But let's just say you've suddenly noticed a lot of load on the green app there. What do? Do you spin up a whole other application server even though the other ones aren't having any load? it's not really ideal. You just really want to spin up the green app over and over again. If you've got, say, a marketing campaign running, you might want 10 different sort of green apps running. It also, in this particular case, you're a bit locked with the legacy system because the database has suddenly become a canonical format, which means you can't easily change the underlying technology of the database without changing the legacy system as well as your apps. So again, if this is an example, so if we had a campaign running, we'd have to spin up a whole other application server with this infrastructure. This is ideally what a microservice layer should look like. So we have the gateway layer, which I mentioned before, coming in. It would proxy through to your microservices. Your microservices are the only things that know about the storage technology behind the scenes. So the only interface in to get the data is via the microservice. So again, as you get more load, you can spin up multiple apps, which should all be invisible to the end user. So you might have sort of round robining, etc., to each of the applications, each of the microservices that are running. That's kind of microservices really in a nutshell. Again, they REST is a common way to implement the microservices. So ubiquitous language. So this is again coming to the concept behind microservices is all around having a ubiquitous language. So ubiquitous language really means the business, the users, developers, everyone's sort of talking the same language. So the systems are generally designed around real business domains and real business problems. So if we have a look at the very first quote there, people get distracted by technology. We want to bring that attention back to the business domain. So I think that's kind of key as well. It's really everyone needs to be on the same page. It's really the crux of it. And people do get concerned about how big a microservice should be. So really a microservice should be as big as it needs to be, which sounds a bit strange, but a microservice doesn't have to be tiny as long as it fits with a real sort of business domain. That's your sort of target audience there. So I'll talk about some common problems now. One common problem with APIs and microservices is sort of buy-in. So you need buy-in across the entire company. So if we take Amazon as an example, back in 2002, the CEO, Jeff Bezos, he basically sent out a mandate to the entire company. I won't read it all out, but basically saying every team, everyone needs to communicate via REST. Everyone needs to use microservices. And if you don't, you're going to be fired. Thank you, have a nice day. So that's quite a push from the very top level. And while this is sort of, it's quite extreme, I think you do really need a push from the top level. It's quite hard to sort of come from the ground up. So you need sort of buy-in as high up as you can get it, basically. So what does this actually mean? So suddenly, across the entire company, every team had to take ownership of their domain. They had to expose their domain to other parts of the company, and they had to sever any links to any external domains that weren't via API. So that's a massive shift. So this is back in 2002. Obviously, this worked out well for Amazon with AWS, etc. But it's, again, a big change. So another common problem is process. So ideally, it comes down to, again, ties in with ubiquitous language, etc. The team should be focused around sort of business domains. So kind of Agile is often quite a good fit for this whole sort of process. Because if you think, I guess a lot of people do sort of what a Scrum fall, where you have maybe 2 years of requirements up front, maybe takes you 3 years to develop, and then you get something at the other end that is still not what the users actually wanted. So it's kind of a lot of people still doing this hybrid process, which works kind of, but it's not ideal. Especially considering, well, there's a study done in 2011 which actually suggested heavily that you might have requirements today, but they have a half-life of 6 months. So if I have 10 requirements today, it means in 6 months' time, 5 of those will be irrelevant. So that means you really need to get things to market as quickly as possible, which is where sort of agile and continuous delivery sort of kicks in. So another process item really is team empowerment. So Amazon have a motto: you build it, you run it. So it's quite a respected opinion, I guess, across the industry these days. So if you have an agile team, they know the business domain inside out. They know when their code's gone wrong. They understand the business problems that may happen as a result of issues. So it's again closely aligned to the business, and teams know the code inside out. So that's really key to that as well. I should also mention with team empowerment, the teams may be stronger in different technologies or think certain technologies are better for the job at hand. So teams ideally would have a bit of empowerment to choose the technologies that best fit. So this ties into it all as well. So delivery. So you need to be able to, again, write code in an apt fashion, but you also need to get that to market. So this is where DevOps really come in. So I touched on this with microservices, but microservice should really be sort of a container. All of the config for that container should be stored in source control, should be able to push that out and spin up any new sort of apps that you really want as quickly and as simply as possible. And it ties into the simplified continuous integration and delivery. Basically, every time you write code, there should be tests written against it. It should be very simple to deliver that code. And a good DevOps team will help you with host managing, containerization of your code, etc. So it is important to have a very strong DevOps sort of influence. Maybe a team, maybe DevOps included in each team, what have you, but it should be a focus. So in summary, really APIs help you unlock your siloed data. So data is no good to anyone if you can't access it. Help to enable bimodal IT, so quick time to market, improve interoperability with other systems, and can enable monetization of your underlying data. Gateways are a key piece to the puzzle in managing all of your APIs, and you really need to focus services and teams on real business domains. There we go. Do we have any questions?